Hello, welcome to part 3 of solving a test question involving simplifying the expression. In this part 3, again, I'd like to review some important skills you need to know, exponents review, and substitution property. A couple of things we're going to talk about here, so I'm just going to jump right into it. Here we have a value of x raised to the exponential power of 0. So anything raised to the power 0 of 1, you could have 1 million, billion, trillion Google to the 0 power. It's still going to equal just one value. Let's go ahead and take a look here. And I'm showing invisible ones here, right? I'm showing an invisible one. So normally you would just see X, right? And so I typically use as an instructor dot, 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 dot. This is X to the first power. But many times you're just going to see an X, right? This is 1x. So I show the invisible 1 in front of that x. It clarifies a lot of what we have to do when you're working with exponential powers. Hey, check out my video on invisible ones. It helps to clarify mathematical procedures that you're going to want to perform. So here, what is x squared? Well, x squared, you need to understand the rule. When you multiply, and this symbol means multiplication, and the bases are the same. X and x have the same base, right? You keep the base in your answer. So I'm explaining how to understand where do we get this x squared. So I'm writing this out in expanded form to explain that. There's an invisible 1 in front of this x. There's an invisible 1 in front of this x. What's 1 times 1? Hey, that's 1. And you got to keep that same base, x. The rule when we multiply is we add the exponents. So if there was no exponent showing here, you may be confused. So I show the dot, dot, dot invisible 1. So what is 1 plus 1? It's 2. So this is x to the second power. So this is kind of explaining how we get x to the second power while reviewing what the rules are. Now, I use a dot, dot, dot to show the invisible ones. Hey, you could write 1x times 1x is 1x. You can write 1 plus 1 in the exponent's place and show that it's x to the second power. It would all be equal to each other. Again, you can show these exponential values if that helps to clarify your steps. So let's take a look at another example here. X to the third power, right? So what is x to the third power written in exponential form? It's 1x times 1x times 1x. Again, 1 times 1 times 1 is 1x. That's the invisible 1 in front of that x. And when you multiply, the bases are the same. You keep the same base. You add the exponent. So each of these x values has an invisible 1, right? So 1 plus 1 plus 1 is 3. So that's why when you multiply x's 3 times, 1x times 1x times 1x is 1x. The rule is you add those exponents when you multiply. We end up with x to the third power. So hopefully this is helping you understand some of the rules regarding exponential powers and multiplying when you have x's. Now the rule is opposite when you divide. When you divide, you would subtract the exponential powers. I'll be showing you those in later videos as it relates to what we are working on. So here, substitution property. In order to solve this test question example, you're going to have to understand substitution property. So here's the expression 3x. If x is equal to 2, I can substitute 2 everywhere I see an x in the expression or the equation, right? So that's what I'm showing you here. I'm substituting 2 for x. I'm showing it here. Anytime you have a number next to a parenthesis or a term like x, it means multiply. So 3 times 2 is 6. I've used substitution property to simplify this expression. I'm going to get into another example here. And again, if I'm going too fast, please stop, pause, rewind. Do whatever you need to do in order to understand what we're doing. Here's another expression, 3 times y, right? And if y equals 1/2, I can substitute 1/2 everywhere I see y. So this means 3 times y. I'm going to substitute 1/2 where the y is, and then I'm going to multiply 3 times 1/2. Now remember we talked about those invisible ones? There's an invisible one in the denominator's place underneath this 3. And I'm going to show you that now. It clarifies. Show those invisible ones. It will clarify what you need to do. And when you multiply fractions, you multiply top to top and bottom to bottom. This is helping to clarify what you need to do. So 3 times 1 is 3. Invisible one, or 1, times 2 is 2. I've simplified this term to 3/2. Now, anytime you got a fraction that's top heavy, in the numerator's place there's a 3, in the denominator's place there's a 2. This fraction's top heavy, right? This is called an improper fraction. So you can divide bottom into top and get a mixed number, which is 1 and 1/2. I have some videos on converting mixed numbers to improper fraction to mixed numbers. Sometimes in your A, B, C, D options, they want it in one form or another. So that's an important skill that you're going to want to review. I have another example of some substitution problem values. Let's go over some of these. When x equals 2, I've got an expression. And the difference between an expression and equation, equations have equal signs, expressions do not. So here, x equals 2. I have an expression 3x to the second power plus x. Everywhere I see an x value, I can substitute what x is equal to. So I can put substitute a 2 here. It'd be 3 times 2 raised to the second power. And I can substitute a value of 2 here for this x. Now, you're going to want to follow that order of operations if that's what you're going to be doing, right? And so the order of operations says inside the parentheses first. There's nothing I can do inside these parentheses. So then I'll move to exponents. Is there anything I can do to simplify the exponent? Sure. Well, 2 to the second power is 2 times 2. So in this next step, I'm going to show you that we need to simplify that expression, exponent in the expression, excuse me. So 2 squared is 2 times 2. Now I'm going to think, I want to review the order of operations. Is there anything inside the parentheses I can do? Well, over here, nope, that 2 is all by itself, but 2 times 2, I can simplify inside the parentheses. So it's each step, you're thinking order of operations. 2 times 2 is 4. So in this step, do I have any parentheses? I do, but there's nothing inside that I can do. Okay, so then I ask myself, are there any exponents here? No, no exponents. Okay, can I multiply and or divide? Yes. 3 times 4, I can multiply. And everything else I'm just going to bring down and rewrite. So what's 3 times 4? 3 times 4 is 12. And then again, I just bring down that plus sign and I bring down the 2. So I've got 12 plus 2. Any parentheses? Yeah, but there's nothing inside that I can do. Any exponents? No. Can I multiply or divide here? No. Can I add or subtract? Yes. 12 plus 2 is my last step. I show that here. 12 plus 2 equals 14. Hey, math is easy. Thank you for joining me in part 3 of review in order to answer the test question on simplifying an expression. Hope this makes math a little bit more easy. Thank you. Take it easy step by step.